Dear students, in this video we are going to see the part B, that is data pre-processing for the experiment number 1 of the course Machine Learning Techniques. And these are the steps to implement the data pre-processing. First we have to import the necessary libraries. Next we have to read the data and we have to perform the data pre-processing. In this experiment, we are going to do the pre-processing techniques such as data cleaning, data reduction and the data transformation. Since you know, in any data science process, data pre-processing is a very important thing. After collecting the raw data, the data are not in the consistent manner. So the data need to be cleaned in terms of or pre-processed by cleaning or reducing the unwanted rows and columns and transforming into a normalization or a scalar method so that the data will be fed into a machine learning model for further analysis. And data pre-processing. So data pre-processing is a process which will prepare your raw data so that it will be suitable for your machine learning model. So cleaning means we can clean your data either by filling the missing values or removing the outliers or smoothing the noisy data. Data reduction. So data reduction mainly deals with reducing the data size either by removing the redundant data or we can use the functionalities called as feature extraction and the feature selections. And data transformation. So data transformation mainly we have the normalization so that the data in one range will be scaled to the another range. Data cleaning. So data cleaning is a process of removing incorrect or corrupted or duplicated or incomplete data from the data set. Because if I have a bad or wrong quality of data, that will affect my machine learning process, so that these data to be cleaned in the beginning of the machine learning model stage itself. So first, in this data cleaning, we are mainly concentrating on checking the missing value and replacing it, and finding the duplicate values available in the data set, and finding the outliers. And to find the missing values, and after finding the missing values, we have to replace the missing values with a new value. So that is called as data imputation. That is replacing the missing values with the new value. So there is some criteria when we have to do the data imputation. In a particular column, if you feel there are less than 10% of data is missing, then it is preferable to do the data imputation. But consider some column having most of 80% of data is an empty value. So if you do the data imputation also, it will affect the performance of your system. So the general criteria, if the particular column having less than 10% of missing value, you can go for data imputation. So how we can replace these missing values? So there are various techniques. We can replace the missing values with mean, median, mode, random value, or by using the interpolation techniques such as linear, nearest, polynomial, and also KNN imputer. And next is checking for duplicates. And here in finding the missing value and replacing, it will not reduce the size of your data set. So now the next thing is checking for the duplicates. So maybe some one or two instances or some instances are duplicated in your data set. So either in all the feature wise the data can be duplicated, or in almost 50% of the features the data can be duplicated. So we need to check for the duplicate and detect the outliers. So since in the last video itself we have seen what is an outlier, how to detect the outlier, and the same concept here we are going to do it. And these two, removing the duplicates and detecting the outlier and removing it, so these two will leads to data reduction, because once I identify the duplicate value, I will try to remove it. So the size of the data set get reduced. And after detecting the outlier also, I will try to remove it. So the data get reduced. So this two I am going to consider in my data reduction. So the first thing in a data cleaning, so first I have to identify the percentage of missing values in each column. So while you consider here, the Python function is null.sum will give you which are all the columns, how many rows are having the null values. Okay. So in that, using these Python function as a background, we have to hard code so that I need to extract which are all the columns having how much percentage of missing values. So if you see here, this having a missing value. So I will calculate. So totally my data set having 150 values. So I need to calculate the percentage of missing value for this particular column. So from out of these columns, I have totally 3 columns having the missing value. So I need to calculate what are the 3 columns having missing values. And this will be dynamic based on your data set. So the 3 columns and the corresponding percentage of missing value. So 14 divided by 150 into 100. So that it will come around 9.33 percentage. So like that, if I calculate for this, it will come under 3.33 percentage. And here it is 8.0 percentage. So already I have told you, if a column having less than 10 percentage of missing values, I can prefer to do the data imputation. So how I calculate this using a programming concept. So as I know, by using is null.sum, I am getting the corresponding columns which having a null value. So from that, I know what are the columns. So I need to use with my for loop. The for loop specify the columns from my data frame. And I need to find next which column having the which column. So d of I dot is null dot sum. So from this first time I will identify the sepal with column. So I will just print it, the column name which having the null value, and followed by I need to display what is the percentage of null value. So I need to take, so this is actually df, that is my data frame. So df of I dot is null dot sum the value. Okay. So for that I need to calculate the mean, that is I am getting the average of 14 divided by 150. So after calculating the mean, I multiply that value with 100. So this will display a numerical value with the decimal. So I need to round off to 2 digit. So I just put round it. So this will return me back 9.33. So I am displaying the corresponding column name with the percentage of missing value in this corresponding column. So that I repeat it. So that will display for the color and the diameter. Next. So we need to replace it. Okay. So whenever I replace the missing value, if it is a numerical column, I can have my mean, median, okay, mode value, then the nearest neighbors, that is interpolations. So all the things I can use it. But if I have a categorical column with the missing value, I can replace generally with the mode value. So first I have to, this also I need to do dynamically. I know now the 3 columns are having null value. So out of the 3 column, and this is the numerical column, and this is also numerical column, but this is the categorical column. So after extracting the 3 columns which having null values, next I need to identify which column having a numerical column. So since you know how to know a column is a numerical value, in the previous video I have explained how to identify a particular column is a numerical column. So once the column has identified, you know the name of the column. So you need to use with name of the column. From the column I need to calculate the mean value, because I am going to replace all the missing values of that particular column with the corresponding mean of the column. So I calculate the mean value, and I know a Python function which is called as fill null values. So for that specific column, using the fill_now method, I am passing the new value which should be replaced in all the NaN values. And if I want to maintain the changes in the same data frame, I need to put in place is equal to true, so that all the null values get replaced with the new mean value. In the same case, if I need to do the replacement in the missing value of the categorical column. So as I already told, using my programming way, I need to identify which column is a categorical column. After identifying the categorical column, I need to specify the categorical column name dot mode. Okay, so this will return basically an object array. So I cannot directly use m to replace the value. So it will actually return the index value and what is the mode value. So here the mode may be green color, means the green is occurred more times and that index value is 0. So I need to specify the column dot fill_now m of 0, comma in place is equal to in place value. So if I do this, the corresponding categorical column with all numerical value, all NaN values will be replaced with the green color. And now we need to replace the missing value with interpolation. So interpolation is nothing but estimating the value. So estimation can be done by a linear way or polynomial way or by using the nearest method. So in order to do that, you need to use with the method df. So the particular column name dot interpolate. We have a standard function interpolate. We need to specify which method you need to use for interpolation. So if I use a linear method, it will use a linear method to estimate the value and it will replace that value with the corresponding null values. And there is another method called as KNN imputer in the scikit-learn. And this will work for in a two-dimensional array and also it will work for only numerical values. And it is something called as your k neighbors. So based on taking the number of neighbors in the n value, it will decide the NaN values based on its neighbors. So here you see here all the things are in a two-dimensional array with all null values in the numerical columns. So when I call this KNN imputer, automatically these null values get replaced based on its neighbors, that is by calculating the KNN neighbors. And now we are going to the data reduction. So data reduction means it is a reduced representation. So either it can be in the form of feature selection or it can be in the form of feature extraction. So this thing we are mainly going to concentrate on experiment number 2. So the data reduction, what I have considered here is just dropping the missing values, drop the outliers and dropping the duplicates. So I need to drop some columns or rows based on missing value or based on outlier or based on duplicate occur in that particular data set. So I want to drop a specific column with the missing values. As I already told, it is acceptable. You can do the data imputation if your missing value is less than 10. So if the particular column having a missing value greater than 10, then I can consider that column need to be removed. So you need to hardcode the code. Already we have known how to calculate the percentage of missing value in a particular column. Using that information, we need to identify which column having the missing values greater than 10%. So that column name, you generally get it. So that column name is ready. Okay. So what you have to do is you have to drop the column. So in Python, we have a function called as df.drop. So you need to specify the column, what you want to drop, and then followed by it is a column, so you need to use with access, and if you want to make it temporary or permanent, you need to use with in place equal to true. So here only change, instead of giving this I just give the column name. Okay, so df dot drop, I need to specify the column name, access value and the in place value, because this will give the values in that particular column. So you just give the column name in the drop so that particular column gets removed. How will you identify the column? Already you know how to calculate the percentage of missing value. Based on the percentage of missing value, you decide the column name and pass the column name here. And now drop the specific row for the outliers. So in the first experiment 1A part, we know how to calculate the z-score to identify the outliers. So z-score will be calculated based on the mean and the standard deviation. So since you know your z-score value is greater than 3, that data point is the outlier data point. So here if I see here, this are outliers. So for this particular column, I need to calculate the z-score. If I calculate the z-score, this value becomes greater than 3, this value becomes greater than 3, this value becomes greater than 3. So by using df of column, I can able to identify the particular column. Then I need to specify which row it is, okay, which row it is, so that I can identify by using iloc. This specify the index of row. Okay, so by identifying the row index, you can able to just drop the rows. Okay, so how will you do the code? So we can write df dot drop, and then we need to specify index is equal to df dot index of which index you want to replace, that index value followed by access equal to 0, because now we are deleting row wise, and then we pass with the in place. So this I value first I have to identify. So I need to specify the particular column. In that particular column, I need to take that particular row value, that is by using iloc. I need to check if the value is greater than 3. If the value is greater than 3, that index value I got it. So that I value I pass it in the drop function. In the access is 0, so that particular row get deleted. So this thing I need to actually repeat in a for loop for every instance. I need to check the z value. Based on that, I need to remove that particular value. And next is finding the duplicate rows, and then it has to get dropped. How to find the duplicate rows? So we have a function called as df dot duplicated. Okay, so in that the first option you have subset equal to none. If I put subset equal to none, it will specify the particular duplicated rows, all column values are same. Okay, the two rows I take, if they are duplicated means all its feature values are same. That's why it is subset equal to none. And then you can have keep equal to false, means if two rows are having a duplicate value, first row only displayed, any one can be kept. And then suppose I need to identify at most some 3 features are duplicated, some 2 features are not duplicated. Okay, so we can use with df dot duplicated, okay, duplicated subset. You need to give, I need to identify the duplicates on which are the specific columns. So column 1, then column 2, and then column 3. So out of these 3 columns, whichever rows having a common values, so that rows I am displaying as a duplicated rows. That rows I am going to display as a duplicated rows. Okay, so this will display the rows which are duplicated for all the columns. This will display the rows which having a duplication only with the specific columns, column 1, column 2 and column 3. So this will identify what are the duplicate rows. Now how you have to remove it? We have a function called as df dot drop duplicates. So by using the function, you just pass the same criteria whatever we have discussed earlier. If I give subset equal to none means it will check for all the columns having the same value. If I put subset equal to specific column, it will check for the rows which having same value or duplicate value in the specific column. So based on this df.drop underscore duplicate, you can drop the duplicate rows. And now the last part is the data transformation. So data transformation is the converting the raw data into a suitable format. So generally we can tell this as called as normalization. Okay. So we may have a data with the range of some 35 to 150. We need to restrict that range with the range of 0 to 1. So that is generally called as normalization. So the normalization can be done in two ways, that is by using the min-max method and the z-score method. So we have some set of formulas. Using the formula, we try to convert every values of the given range into a new range of 0 to 1. So first we have this data. We'll see how to do the min-max normalization. So the minimum value I have my data as 3 and the maximum value I have it in my data is 34. Okay. So as I told already, I know that for a particular column, I need to take a particular value, the first index or like this. So now I need to take this value and I need to find out what is the corresponding normalized value of 8. Now the minimum value is 3, maximum value is 34. The new range I need to do with 0 to 1. So whatever value is between 3 to 34, that I need to normalize to 0 to 4 as a new range. So I take a column, then I know that how to identify a particular row, that is by using this index. So it can use a for loop, retrieving it, I take this particular value. Then there is a formula, what is the new value for this 8? The new value for 8, okay? So that is the old value minus minimum divided by maximum minus minimum, and then followed by what is the new maximum, what is the old maximum, new maximum and the new minimum plus new minimum. You can just go here. Yes, so the old value minus the old minimum divided by old maximum. These are all old. Okay, old minimum, and that you are converting into new maximum minus minimum plus minimum. So whatever value if I give, that will be now converted into a range of 0 to 1. That is my new range, 0 to 1. So 8 minus 3 is 5 divided by 31. Okay, so this belongs to a value 0.161. So automatically now 8 will be moved to a range of 0 to 1. So this scatter plot helps you to recognize or understand this. Initially your data points are in the range of 3 to 34. Now it is restricted to minimum value of 0 and maximum value of 10. Sorry, maximum value of 1, 0 to 1. So now z-score normalization. So z-score, you know that how to calculate the z-score. The z-score will be calculated based on mean and the standard deviation. Okay. So if you see here, this will be distributed based on the normal distribution. So it makes all values will be less than 3. So you see here, whatever value I am having, that will be distributed between less than 3. So if I observe it, if I have the mean value is 14, okay, so all values less than 14, all values less than 14 will be represented, less than 14 will be represented as a negative number. All values greater than 14 will be represented as a positive number. Okay, the 14 is nothing but the mean. If you calculate the mean, then if I have the z-score value, all my z-score values, that is, if it is less than mean, the value, the input value is less than mean means my z-score is in the negative. My z-score is in the negative. If my input is less than mean, my z-score is in the negative value. If my input is greater than the mean, then my z-score is in the positive value. So by taking each component, okay, each instance by using the column name dot I log I, you calculate the corresponding Z score and try to scatter, plot all values. Initially it is from 3 to 34. Now it is restricted to less than 3. And now there is another one transformation method which is called as encoding. So encoding is nothing but converting the categorical features into a numerical features, because machine learning algorithm will understand only the numerical values. So since my data having a categorical column, label data, so this label need to be converted as a numerical value. So how it is 0, 1 and 2? So it is India, Japan and then US. So India will be replaced with the 0 index, and then Japan will be replaced with the index number 1 and US will be replaced with the index number 2. So in Python itself we have the predefined methods that will do with label encoding and one-hot encoding, but now here it is expected you need to write a hard code so that you try to convert your input based on the label encoding and your input based on the one-hot encoding. So one-hot encoding, so the 3 unique values I have, that will be created as 3 columns in my original data. So wherever the India is there, that column will be 1, remaining all will be zeros. Japan, wherever that particular instance is true, that you having the value 1, remaining is 0. US, and these 2 instances having the label, the others are 0. So it will create some additional features or dummy variables, and it will label with zeros and ones. Now how to do it? So this is my input. So this is my categorical column. So I know the name of my column. So df of column. I got my categorical column. So from this categorical column, I need to know how many unique values are there. So I just put unique. So this will return me back what are the unique values. So it will be displayed generally based on the alphabetical order. Okay, alphabetical order, it will have India, Japan and US. So what I have to do in my input, wherever India comes, I need to replace it with 0. Wherever Japan is there, I replace with 1. And wherever US is there, I need to replace with 2. Okay, so I need to use with my for loop. So inside my for loop, I need to just use a function called as replace. So df, the corresponding column, I need to use with replace. Okay, wherever I am getting u of I. So initially it is India. Wherever India is come, it should be replaced with I. Okay, replace with I. So I means u of I means India. This I means the index value. Like that, we have the next unique value Japan, so that will be replaced with 1. So like that you need to repeat it, so all values get replaced. And now when moving to the one-hot encoding, already you know the unique values, but what I have to do is, I have already 3 columns. Okay, so country is there, age is there, salary is there. Okay, after finding the unique values, using my first for loop, I need to add one new column, that is India. Okay, so from the unique value, I know what is my column name. My column name is India. I add with 0. So a column India gets generated, which having all the values is 0. So now what do we have to do? You need to use with another for loop. Okay, another for loop, that I take every country value, df of country value I take, and I check in the I log I, or this I use with j means I need to use with j. I take a first value of the country and I am going to check if it is India. In the India column, I make it as 1. Remaining all column, I will leave it. So I will take this I log, and then I am going to check whether this value is u of I. U of I is India. I take the first instance of the country column, check that whether it is having India. If it is India, you just replace u of I value need to be replaced with 1. So automatically, defaultly what it will do, it will add the next column, that is Japan. Okay, now I becomes 1, previously I become 0, so I become 0 means it is India. Now I become 1 means it having Japan. So now I am just creating one new column with the name of Japan, make it all as zeros. And I am going with each instance taking the country value. First instance checking that whether it is Japan. No. Next value whether it is Japan. No. Next value whether it is Japan. Yes. So this value get replaced with 1. Fourth value not Japan. Fifth value it is Japan. So it get replaced with 1. Like that the outer for loop repeat. It will add a new column US and try to repeat the same process, so that the 3 new columns are added and it will do the one hot encoding. So I think you have understand the basic concepts behind for the part B of the experiment number 1. So using that you can solve these informations, you can read the data, you can create the temporary data frame, because sometimes we use the in place is equal to true means the changes will be reflected in the original data frame. So you want to make it as temporary data frame, you can create some temporary data frames. Then calculate the percentage of missing values and you try to replace the missing values if the percentage of missing value is less than 10%. You identify the columns which are having the missing values less than 10%, you try to do the imputation. And for categorical value you do the mode imputation, and you for some numerical columns you use with the interpolation methods using some nearest method or linear method or polynomial method. And if the particular column having the percentage of null value is more than 10%, then try to drop that particular column. And for a particular column you calculate the z-score value. If the z-score value is greater than 3, drop that particular row. Okay. And next is you need to identify how much percentage of rows are duplicated for all the columns having the same value. So I can put subset equal to none. So it will check for the duplicate where all the column values are same value. So then you can drop it. And next you find the duplicate, how much percentage of rows which get duplicated if I specify with a specific column. So I need to check that particular duplicate rows having the corresponding columns alone having the same value. And then we go with the min-max normalization, and that you can analyze with the scatter plot. Okay, then you can do with the z-score normalization for a particular input column. And you do the label encoding and the one-hot encoding for the categorical features. So here all expected, you need to use or hard code the Python coding to understand how it is working, because we have standard Python libraries, so we just write a function and you can get it, but at the background you need to know how it is working, so that in this experiment you try to hard code the Python coding so that you can able to do all these informations whatever expected from the experiment. Thank you.